I request everyone to rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
भारत माता की now request our chief guest and chairman and secretary to light the lamp and start the function. Yes. Requesting Engineer Bhushan Harshe, Engineer Vibhas Achrekar, Engineer Vivek Abhyankar, Engineer Parag Raut, and our Chairman and Secretary Madhav Chikodi and Srinivasan Mudliar. I request our chairman, Engineer Madhav Chikodi, to kindly welcome our guest, Chief Guest Engineer Bhushan Harshe, and Guest of Honor, Engineer Vibhas Achrekar, to the dais. request our Secretary of Kalyan Dombivli Local Center to escort our guest lecturers on the dais. Huge round of applause for everyone. I now request our chairman for Kalyan Dombivli Local Center of ISSE to start with the address of the ceremony. We welcome our chief guest, Engineer Bhushan Harshe and Vibha Sasrekar, with a small token of appreciation for being here today and gracing the ceremony. We now welcome Engineer Vibha Sasrekar. So I now request our Secretary Srinivasan Mudliyar to welcome our guest lecturers, Engineer Vivek Abhyankar, and now welcome Parag Raut, our second guest lecturer.
I request our team to felicitate Secretary of IIA, Architect Uday Satolekar. I also request to felicitate Madhav Singh of this Globe Banquets, who was instrumental right from booking to all arrangements till date. Thank you, sir, for your gesture. Namaskar and good evening. Today, chief guest, Bhushanji Harshe, sir. Guest of honor, Engineer Vibhaji. Our first guest speaker, Vivekji Abhyankar. Second speaker from Tata Steel, who are also hosting today's event, Parag Raut, sir. I, Secretary Uday Satolekar, ISSE Kalyan Dombivli Managing Committee, because of whom we are arranging this program. Friends, every member of this committee has some unique representation so that we can host such events. This center, Indian Society of Structural Engineers, Kalyan Dombivli Local Center, was formed 2 years back, 2023, with an aim to facilitate stakeholders in civil engineering, namely structural engineers, civil engineers, site engineers, architects, developers. Because we all know we are facing so many issues, so many problems, so many challenges in a day-to-day activity. We all know in 2020, the government come up with UDCPR 2020, and lot of changes are happening. जिधर 4 माले का बिल्डिंग था उधर अभी 14 माले का हो रहा है, जिधर 6 माले का बिल्डिंग था उधर अभी 25 माले का हो रहा है. So many and so forth. So we as a structural engineer, we are facing, you cannot say problems, but sort of challenges. जैसा ग्राउंड फ्लोर का ग्रिड अलग है, फर्स्ट फ्लोर का ग्रिड अलग है, रेसिडेंशियल अलग है, फ्लोटिंग कॉलम्स है, पार्किंग का रिक्वायरमेंट्स है. So it is very difficult to face these challenges. So we decided to come together and form this chapter. Let us share the ideas, let us come out with some solutions. And this is the base where we are sharing our knowledge. With this objective, we form this center, and we are, on an average, we are taking 2 to 3 programs in a year. Again, we aim to train site supervisors. There was a gap between site supervisors and developers. We in Kalyan Dombivli area, some developers cannot afford good quality engineers. So we decided to develop site supervisors to certain technical knowledge. And I am happy that first lot of site supervisors we have certified them, and today we are distributing the certificates. Though the number is less, I am sure their success stories will bring more and more supervisors, and they will get educated. Today's event is hosted by, it was in a very short notice, so I am very thankful to Tata Steel. Friends, we all believe in sharing knowledge because knowledge is power, and our learning should not stop. It continues. Today we'll be hearing to 2 guest speakers, namely Engineer Vivek Abhyankar, who will be speaking on formwork. For formwork, we are always interested to know about how many recycles we are doing, what are various qualities of material that we can use for formwork, then cost of formwork with respect to its life cycle. Most importantly, formwork failure. We are hearing many news that there is a failure in formwork. So he'll be unfolding all these issues in his presentation. And today Tata Steel is coming up with new unique feature of slab reinforcement. हम लोग साइट पे स्लैब बांधते हैं, तो वो रेडीमेड मेश कैसा बनाते हैं और रेडीमेड मेश कैसा स्लैब पे रखते हैं, that they are going to tell us. I am sure sharing knowledge of these both speakers will enhance our ideas and knowledge. So we at ISSE Kalyan Dombivli Local Center assure you to bring such more and more programs which will educate all of us and which will bring ease in construction. I once again thank all of you for joining this program. Thank you.
I request Srinivasan Mudliyar to give everyone a brief of ISSE.
Thanks, Aditya. Good evening, everyone. On behalf of ISSE KDLC, Kalyan Dombivli Local Center, I, Srinivasan Mulya, Secretary, take great pride in sharing our journey, progress, and our vision with you. It was formed, as said by Chikoti sir, 2 years back, and we came together to collaborate, contribute to the construction industry, and I would take pride to introduce our committee members. I'll call up the names. Please recognize yourself wherever you are. Chairman, Engineer Madhav Chikodi sir. Secretary, myself, Srinivasan Mulya. Treasurer, Gopal Bennur sir. Our committee members, Amod Luman sir. Engineer Manohar Patil sir. Engineer Aditya Deshmukh. Engineer Girish Marathe. Engineer Rajesh Thakre sir. Engineer Ram Marathe. Engineer Nayan Dholke sir. And Engineer Rajendra Paranchve sir. So this is the A team behind today's event and all the events we had last year. Sir, one of the major achievements we had last year is training of the site supervisors, which was a challenge. A huge gap between the technical team sitting in the office and those illiterate laborers who are working on site. And we tried to educate them in a most practical way so that they implement all the technical things on site. This was held in 5 sessions, which was attended by more than 25 supervisors, held at Tilak Nagar Vidya Mandir School. And the lectures were given by Chikodi sir, myself, Engineer Ajay Kulkarni, and Engineer Raju Prabhune sir. Yeah, sitting at the last chair. And the feedback we got from the supervisors as well as from the team where they came from was phenomenal, as well as from ISSE, other local centers as well, because they also plan to introduce such supervisory course in other centers across India. Another initiative that we have taken is we have met KDMC authorities till the commissioner level to include the names of all the M-panel structural engineers in their website to dissolve all the confusion that is among the citizens, which is taken up, and it has been assured that the names will be on the website. Our vision for the year is to make college chapters. We are already in touch with Dattamage College of Engineering, Episha Institute, and MGM College to start ISSE student chapters so that we will have the future structural engineers who are already well groomed for the future. So in short, this local center is moving with the intent and the purpose what we came for. So thanks for all your support. And with this, let's move on for the program of the day and we'll hear the speakers. Thank you very much.
I request our chief guest and our speakers to make yourself comfortable before we start with the lecture. Thank you, sir. Yes. Our first lecture would be by Engineer Vivek Abhyankar. I would like to call upon Gopal Bennur sir to give his brief introduction before we start with the lecture.
Good evening, everyone. I am giving just brief report about Mr. Vivek Abhyankar. Mr. Vivek Abhyankar is a founder of SJ Wings Civil Consultant Advisor Private Limited, founder of. He is having almost 27 years of experience in different kind of work like designing, execution, as well as planning. He has done a lot of work in metros, bridges, buildings, and tunnels. He is also gold medalist from the University of Mumbai from PG in structural engineering. In the past, he worked with HCC, FCON, L&T, and other big company where the major project has been done in Bandra, Varla, Sea Link, Kolkata, underwater metros, etc. He was faculty in VGT and Space for Bridge Engineering. Apart from that, he has written a lot of technical papers and contributed 3 chapters in top-rated books. So let's welcome Mr. Vivek Ambenkar for his.
Will say that what I'm going to speak, what's different in it. But there are so many things which we have not understood or which are not taught in colleges. So I'm just going to touch upon important things in this 35 minutes. And there are some case studies which I have brought, and there is some theory part of it. So 25 odd minutes I'll speak on the theory part of it, and 10 minutes I'll touch upon some good case studies and some failure case studies. So it's really a challenge to, gagar mein sagar bharna. So form work is like that. So let us start with what I'm going to discuss is why to learn form work. It's a temporary structures. It's going to be wrecked off. Temporary है, क्यों उस पे ऊपर इतना ध्यान देने का? Okay. And what are the recent developments which are happening in this sector? I'm just going to discuss with you. I'll start with some brief history, classification, terminologies in the form work, because we generally feel it's a temporary jugaad. Okay, but there is a lot of engineering hidden in it. So I'll just discuss about that. Then steps involved in design and planning of the form work. What are the guidelines available? What are the codes and standards available? Then planning for the form work. What is the time cycle? What is the pour rate? What is the pouring sequence? So all these small things affect the success of the form work. Then I'll talk about important points in execution of form work and staging. What is the productivity norms? What are the mistakes which we do? And there are certain other topics like shelf life, tagging, then disposal, air volume ratio, and life cycle cost. These I am not going to discuss in today's presentation because it's practically impossible to discuss entire topic in 35 minutes. So I'll be keeping some curiosity, with you. So to learn this topic out more and more. Then there are a few case studies, and then there are some question answers we can have. Can you remove that sofa so that the screen is visible? Because there are certain small things which will be coming. Just shift it, straighten it, yeah. There's no audio coming. There's no audio.
Okay.
I'll just go back. I'll start again. Should I? No. There's no audio coming. put a mic there. Put a mic on the laptop. That's more important. Should I start? It's not coming. I think it's not catching signal from here.
It's a massive construction project. The completely man-made Jumeirah Island in Dubai. A long crescent. It's a massive construction project. The completely man-made Jumeirah Palm Island in Dubai. A 12-kilometer-long crescent breakwater protects the palm-shaped island from rough seas. From here, a 1.4-kilometer-long access tunnel leads to the inside of the palm. For this, Perry supplied the complete formwork. Using cut and cover method, the bottom and slabs were concreted. The 600-meter-long centerpiece of the tunnel will eventually be submerged underwater. The tunnel base is in part over 2 meters thick, and thus a requirement in order to prevent the structure from lifting. The above-average slab thickness also helps to weigh the structure down. Due to its tremendous flexibility, Perry Vario was selected to be used as the wall formwork. The Vario Whaler and the proven GT24 lattice girder were also used for forming the slabs. The extremely large slab loads were transferred via PD8 towers. Once installed, the tower units could be moved from one concreting section to the next. Within just 11 months, 200,000 cubic meters of concrete were used for construction, until the gigantic project was finally finished.
Yeah. So when we talk about formwork, there is a when we talk about formwork, we are all aware about this situation, okay, where we have jugaad technology, bamboo ballis, you know, unengineered material lying at site, and then there are a lot of kilas, you know. When I was working at site, in year 95, when I got a first kila in my shoe, you know, my boss said, now you're engineer. But now that situation is gone. So what we have today is a very engineered formwork, and in olden system, you don't know from where, what is going, how the load is getting transferred. Whereas in new system, you have got a very defined system. I am not advocating here any particular company. I am just telling you about the engineered formwork. So what do we know about the modern formwork system or the engineered formwork system versus the old formwork system is the simple load transfer. Then they are safe and auto climbing and self-assembling type formwork systems are available. It's time saving, it's less noisy. We are thak, thuk, you know, drrr, and then there's a lot of noise which is happening in the old system which is no more there in the new system. But what is discouraging people is the high initial cost of the modern system, which we feel, and I'll prove that how it is wrong. Then long-term cost of the life cycle cost of the modern system is very, very cheap, very, very less, and it's having a long life. Okay, so overall it's engineered and this is non-engineered. Okay, कुछ design ही नहीं किया गया था. I'm not advocating any company or any particular material, but I am saying that if you take the old system and properly engineer it, you can still use it, olden materials, okay. So you have to just engineer it. So what to engineer and how to engineer, there are so many codes available. Now I have taken one typical case study wherein you can see that the formwork material cost was 8%. And the sundries and the labor cost was 27%, and total cost raised to 35%. If you go for engineered formwork, then that 8% shoots up to 20%. And many people say, नहीं यार, मेरा 8% का formwork मैं 20% क्यों involve करूँ? But the 27% labor cost reduces to 15% because it is well engineered. There are definite hooks given for lifting, there are lifting eyes given, and overall cost is 35%. The other one is also coming to same 35%, but this 8% he is having a life of only 1 to 2 years, max 3 years. Whereas the engineered formwork where the cost is 20%, the life is something like 10 years or 15 years. Okay, and if you take a typical 3 years, then this 35 you will have to add 27%, again 27%, so that will shoot up to something like 90%. Okay, so 90% divided by 3 is 30% cost per year you are incurring. Whereas if you take 20% plus 15 plus 15, then that comes to 18 to 20% cost per year for an engineered formwork. So it looks apparently costly, but ultimately it is economic. Formwork is consuming major part of a project. So this is one example which I took from one of my old projects, and it is not taught in colleges. Such an important subject. We teach concrete technology, limit state method, this thing, that formwork is not taught in colleges. Why? Jugaad, temporary works. Maximum members are failing during construction. There is a lot of construction failures are happening. And now what is happening? There are a lot of new technologies being coming. CNC, drone, CC, VR, visual reality, AI, and so many things are being used in formwork. Then if we know, last year alone in Bihar 18 bridges collapsed during construction. Lack of formwork knowledge, lack of knowledge of erection. I asked sir ki I will speak on erection, but he said ki no, last session you spoke at Mahalakshmi, our people couldn't come, so please speak on this topic because it's a neglected one. Then changing technical specification. अपने को पता ही नहीं है formwork में क्या चल रहा है, what are the codes available, what are the standards. Okay, how many of you know this lady? She's M.K. Hurd, Mary K. Hurd. She is called as the queen of concrete. She wrote a first code, ACI code on formwork, and later that was converted into a formwork book which is called as a Green Bible. Okay, so she has started the entire documentation, formally doing. Okay, there are so many other people, but she has got a unique position. Like in concrete technology, we say A.M. Neville. Okay, in formwork, in geotechnical Terzaghi. So like that in formwork, Mary K. Hurd has a unique standing. Then there are so many new companies which are coming up. Now let us see the history of formwork, how it started. In 1908, they were in ACI in America, they were discussing whether to use lumber or steel. They were debating. And now what is the situation? Steel formwork is mandate there. It's a rule, mandatory in road construction in US. So it's very, very important. So we have started from zero to like hero, okay? But still among consultants, among civil engineers, we feel temporary hai, pata nahi apne ko. Going ahead, formwork can be classified into various heads. How to classify it? Based on material, based on usage, like steel, timber, plastic. There's so many ferrocement, so many materials we can use. Then based on use, building formwork, high-rise, bridge, based on position, wall form, soffit form, column form. Each unique type has got a different characteristics. The load defined in the codes are different. The usage is different. So that we have to understand. अपने को सब सेम दिखता है, जैसा हम लोग बोलते हैं ना काला अक्षर भैंस बराबर, वैसे many people feel formwork है तो same है, but there is a lot of engineering in it. There is a lot of types in it. Based on repetitions, we can classify multiple use, single use, sacrificial formwork, based on mobility, stationary formwork, traveling, jump formwork, slip formwork, voided formwork, then light, based on loads, light loaded, heavy duty. So many things are there in formwork usage. I will be sharing the copy of slides, so you need not to worry. Then based on patent, you have got ACRO, DOCA, PERI, FUVI, RMDK, KNS. I think ISSE had arranged a site visit through KNS last month. Then the ACRO company is closed, and then the British Scaffold, Aadhaar, Unistage, wheel, this wheel fabricators, there's so many offshoots are coming up. Then based on finish, concrete finish, wood finish, aggregate, and so many other finishes, the formwork type changes, the design changes. There are typical terminologies you should know in formwork. When we say formwork and when we say centering or staging, the formwork is the one which is in contact with concrete. Formwork को support करने वाला जो रहता है, wailer and all those things, that's centering. And उसके नीचे जो column लगेंगे, that is called as a staging or supporting or cribs. Then you will have further components like skin plate, stiffener, bend press plate. Okay, and in formwork you have further connections like centering truss, clamps, coil anchors, tie bolts, nuts, bolts, so many things are there. And these are the few glimpses of your formwork. I'm not going into detail of each one, but then if you are interested, please get in touch with me. I'll explain each one. These are the typical connections which are there. In back slide, I have shown some of the staging components, some of the formwork component, and these are the joinery which is there. Now let us go into formwork planning, because formwork doesn't start with design, it starts with its planning first. What to plan? And in planning, what is very, very important is the pour rate. What is a pour rate? So pour rate depends on the quantity of concrete to be poured in a single pour. Ambient conditions, capacity of batching plant, transit mixer, concreting devices, distance from source to destination, your type of structure, your project conditions कि कितना टाइम में करने का है, एक ब्रिज आपको 2 साल में करने का है या 1.5 साल में करने का है, how much volume you have to place in one year time. Accordingly, your pour rate will be decided. Type of concrete, whether it is heavy aggregate concrete, light aggregate, self-compacting concrete, type of formwork system available at your site, because you may be wanting to use your old formwork, and desired cycle time and project duration. So I have taken one typical example. I have a batching plant of 30 cubic meter, there is a transit mixer 6 cubic meter, column size is 1.2 by 1.2, 8.5 meter height, and such. One column is having 24.24 volume, such 5 columns per day to be cast. Now total volume to be cast in a day is 61 cubic meter per day. Then the lead distance, I have assumed something 15 kilometer, and there are so many, what is the speed of transit mixer, what is the delay time. So I have just put it in the form of an Excel spreadsheet. You also can do it easily with the help of your planning engineer. What I have arrived is the pouring rate which is required is 4.8 meter height per meter per hour. And this is an extremely fast concrete. It's an extremely high pouring rate. Generally, code says that up to 2.4 is the highest rate which you can design as per Indian code. So for this pouring rate, you have to use some foreign codes which are available. Yeah. Then further we can start design by obtain the concrete dimension. What is a beam, what is the column size, what is the slab size, obtain those dimensions. Then you find out the methodology of putting the concrete. Plan the sequence, whether you want to do bridge soffit first, all the webs, this thing, and then the deck afterwards, or you want to do entire segment, entire ridge in one go. So 2-stage casting, 3-stage or single stage casting, that you will have to fix up first. Then obtain the concrete pouring height, kitna height se pour karna hai, decide the formwork which is based on the nature. Then there are so many parameters like obtain the concrete properties, density. Then based on there are 3 formulas: ACI, Syria and Dean formula. Of course, Indian formula is also there. So decide which formula you are going to use. Then obtain the concrete pressure diagram. Then plan, size and design various components based on the allowable stresses and deflections. Then prepare your GAD or the scheme drawing for the formwork. Then general panel markup drawing, that is fabrication drawing which we call, or a shop drawing, and other things like pour card, testing approval, monitoring. These are all part of formwork which I am not dealing it right now. These are the various codes which are available: Syria 108, ACI 347, wrote by the great lady, Finn of Concrete, Mary K. Hurd. Then there are so many British codes. IS 14687 is a very important code which all Indians should know for formwork. Then there are so many other codes which are available for slip form, for form vibrators. These are the loads which are there to be used: self-weight, dead load. It's a 2.6 you can see. And imposed load you can see 340 kg. Generally our live load is lesser than that in buildings, and if this load is very high, what happens we will see in the failure case studies after few minutes. Then there are lateral loads to be considered, the effect of post tensioning also to be considered on the formwork. Now we discussed 2 things. One is the rate of rise, pour rate, and second is which formula to be used. So I mean just discussing about those 2 things. Suppose there are 2 columns, one is smaller diameter, one is bigger diameter. I put same amount of concrete in them. So you can see a chota area wala zyada bhar gaya upar. Now what happens? I put second batch of concrete, upar aur bhar gaya, aur dala, wo pura bhar gaya upar wala. Okay, itna clear? Now I put another concrete in this thing. What happens? Niche ka concrete set hona shuru ho gaya. Okay, you can see that it is no more. So bigger wall or bigger columns will have a lighter formwork, whereas shorter columns will have a heavier formwork. Okay, so that is called as a fast pour and this is called as a slow pour. This is very, very important thing. Then these are the Syria and Dean formulae. So I am not going in the mathematics of it because we have limited time. But the diagram looks like this, and if you happen to use a wrong formula and if you do not design your formwork properly, what happens you can see in the video there. देखो, formwork pressure ज़्यादा आ गया and formwork खुल गया, it start giving a way to concrete, and last minute hurry worry you can see. Okay, such a wastage of M40 grade concrete. So we have to stop this. Okay, very, very bad pathetic condition. And you will say कि चलो मैं उसमें कुछ coil anchor या ज़्यादा tie bolt लगा देता हूँ. Tie bolt लगाया तो क्या होता है? हम लोग ने try किया, formula was wrong. Put a tie bolts at the base, concrete will bulge like this because it's not designed for that pressure. Okay. Further to that, when we start further formwork detailing, there are 2 more mistakes which we do. One is on the bracing and one is on the unsymmetrical loads. So we know all this diagram. Portal frame subjected to uniformly distributed load. But concrete is not uniformly distributed at the start. It starts from one end. So it is always eccentric load at the start. So when there is eccentric load, you can see there is a sway in the frame. It's very important thing you should note. So there is a sway. So if I brace this frame and this is a symmetric load, if I make it unsymmetric, there is no sway. See the importance of the bracing. The simple 5,000 रुपए का bracing can save your 5 crore का structure. Okay, very very important thing. Now, if you are having a long form work, the bracing will allow the distribution of load. आपने देखा कि इधर में लोड लगाया and deflection दूसरे spans में भी आ गया है. Because bracing will start distributing the load. Eccentric load लगाया, it will distribute the load. IS 14687 says that if you are having a X amount of concrete, out of X by 3, you have to apply eccentric on the formwork. So there is a specification like that. If it is not done like that, if the bracings are not done, what happens? Let us see. देखो अभी वो ट्रॉली लेके आएगा, eccentric load has come. Everything went down. No bracings at all. No bracings at all. Everything came down. Unlucky fellows. Now these are the guys which are lucky fellows. They are not given bracings, but there is no life loss. See, placer boom. The new code says that whenever you are designing using a placer boom, you have to design your formwork for that. This was not known in IRC 87. That clause has come. So these are the various bracing patterns, and at site many people say, many contractors say, sir मेरा गाड़ी जाने का है, मेरा वर्कर जाने का है, हमको एक पैनल ओपन दे दो, bracing वहाँ पे मत लगाओ. Okay, so many नाटकबाजी they do, like alternate bracing. So the last one is a good, best one. Okay, but if you happen to deal with the other, and the top one is the worst one, unbraced is worst one. But बीच का चार जो है, if you are getting it, just consult someone who has done a formwork design. Just don't allow your contractor like that. So this is the best one. Another important thing is connecting the pipes in an eccentric way. So they do not use there is something called the revel pin which they forget, and then they connect it eccentrically like this. So what happens, there is a bending moment generated on the lower pipe because of the eccentric load. This is from my own office. I was shouting at them like, you know, what are you doing? Eccentric pipe, don't try and jute se banda hai. And this, I have taken it from the British scaffold manual. They say this is an unacceptable range, that is a costly range, and this is an acceptable range from the testing of the couplers which are there. So, but then they say ki if you are doing, you have to check the pipe like that. But there could be dent forming if you go with lot of eccentricity. So you have to be very careful while designing the formwork. Yeah. So now this is a typical table. I have taken it from the stripping time which is given in IS 456 as well as IS 14687. So this is a cantilever. You should start removing the props from out to in. This is very very important because the cantilever will start slowly becoming a cantilever. Okay, so like that from outer you should start removing the bullies inward. But many times what happens, client will say या the builder will say कि मैं यहाँ पे एक बल्ली safety side के लिए लगा देता हूँ. Now consultants are very wise. Now what is happening? This is acting like a simply supported beam. Okay, so consultant will give 50% bend back reinforcement so that there are no cracks available. So only the experienced consultants will do like that. And this is a pre-camber diagram which has to be given for longer slabs. Then in formwork, this further important thing is a finish requirement. What is the type of finish requirement? Many of the contractors and builder feel that this is a finish, but this is a mistake, not a finish. Okay, so are you with me? Jaag rahe ho? Okay, so now there are few case studies which I am telling you, few bad case studies and few good case studies. This was one of my Gujarat GSHP 6 site where binding wire they used it. No dog clamp, no bolting was used. Binding wire कभी भी टूट सकता है, उसका capacity क्या है? Corrode हो गया था वो भी. And you can see even the member is bent. It is bent like that in plan. Then यहाँ पे packing के लिए channel use किया, वो गिर जाएगा जब load आएगा तब. And then failure will happen. Consultant को या office में बैठ के कैसा पता चलेगा कि ऐसा site पे हो रहा है, right? Then stacking of the material, they just, human skulls jaisa stack kar dete. You should stack it like this. There are a lot of guidelines available internationally how to stack the material. Okay, not like the one below, the one above is the correct one. So these are complete booklets available for stacking of the formwork. Then packing of the level गलत हो गया, we put packings or shims. But shims देखो कैसा आधा बाहर आ गया है, वो गिर जाएगा तो there will be lot of accidents which is happening. फॉर्मवर्क को क्रिप्स को टाई करने का प्रॉपर बोल्टिंग इज नॉट गिवन, रीइंफोर्समेंट फाउंडेशन को ही बेंड करके टाई कर दिया, शुड नॉट बी डन लाइक दैट. ओके, देन whenever you are having a tall structure, you should give a bracing there. I told you that your live load of the formwork is more than your building live load. Building live load is 0.2, whereas that is 0.36. So if your slab is premature, then failure can happen like this. This is another failure where the formwork was removed before time. This is another failure where bracings were not given. And funny part was, in one another failure, what we found was नीचे में उसके gas cylinder मिला था, तो there could be a blast also. So you have to be very very cautious. वहाँ पे welding चलती रहती है, so many things happen. So there could be a life threat. This is my own formwork which I designed in 2007. Now you will laugh because there is no safety given, there is no walkway, and the engineer has to do acrobat. Okay, so it should not be done. It's my mistake. Wrong. Now I am sitting, I am admitting that in open audience in 25. But now if you give my young engineers sitting there, please don't do like that. It should be pakka safe. This is a friction clamp. It was a world's highest friction clamp which we had designed. Yeah, this was a birthing dolphin formwork. This was a Kudankulam dome formwork, which was an award-winning formwork. Excellent job was done by us, our team. This is a wonderful traveling formwork for Sydney Opera House. I'm not going into the technical this thing because time is nearing to completion. So this is a traveling formwork which you can see the traveler's sketch was given by a designer, and exactly the site is having same thing. Many times what we find, design में 32 का बार दिया और site पे 25 का use कर रहे हैं. Okay, I will have so many case studies to tell about that. So there is exactly जो designer ने दिया, the same thing was replicated at site. There is no 1 millimeter change. So this is a wonderful structure which has come because they were knowing formwork क्या है, कैसा करना है. So this is another traveling formwork, Allahabad Naini Cable Stay Bridge. I was designing in 2002, and I was novice. I was having no knowledge about formwork, and my bosses were completely leading me. So let us quickly see one more small video on a traveling formwork, how it could be interesting. Oh, what is happening? It's an audio. It's not going. There is no audio coming. Yeah, I'll just explain verbally. This is a long viaduct wherein it was a composite viaduct. The girders were in steel and the deck was in concrete. You can see that the complete viaduct, you can see there is a climb formwork system given for casting of piers. And for the rest of this thing, there were two traveling trolleys. One is inner side and one is, and this is a top trolley supporting the entire formwork system. So now they are putting the inner trolley. It's so easy that 4 workers are just sliding it off, okay, because it is put on Hillman rollers. So you can see Hillman rollers there, just slide it off, it's done. Now you start your reinforcement. For outer trolley, they are having an outside Hillman roller. So this man is adjusting that. So once the Hillman roller is adjusted, and this entire viaduct was on a curvature. So now the assembly is being pulled. So you can see that they are pulling the assembly. Outside plus inside is pulled up. And now the Hillman rollers which are there, you can see the small green, red color block. So they will navigate the entire curvature. Now he will show how the entire curvature is negotiated by the formworks. Yeah, so you can see this channel, so here that channel is entering in the entire curvature. So by giving a flexibility, the curvature is negotiated by the entire formwork system. So they are doing the construction. So there is a tirfor and there is a turnbuckle. So lower system is pulled up and locked. Now its formwork is uplifted by chain pulley block. Once it's as a desired level, so you can see the vario beam, and vario beam, and that Perry's truss type beam you can see here.
Power on. Bluetooth mode. Connected.
So the surveying is being done, and now
Within just 8 months,
now you can use
54
that Tata's
cycles were completed
E-mesh,
with the
so
2
that
Perry
it saves
formwork
further
carriages.
time. Because
And
formwork
bridge was
already
completed
saved
on
time. So an entire viaduct was done in 18 months time, which is a record time which for such a long viaduct. Yeah. So this is a conventional bridge formwork which I am showing. So here many people make a mistake that outside there is no load, but lot of heavy cribs are given and even diagonals are missing there. Whereas exactly below the web where there is post-tensioning force is getting transferred, the crib should be heavy, but now you can see outside cribs are heavy. And in one of the case in Karnataka, we had a failure of this sort because the cribs were not given exactly below the web, wrong jagah pe deke rakhe the. And this is a conventional formwork which I did in 2014-12 in for RVNL Kolkata. So you can see this segment formwork, and during construction it is, you can see. Then this was done in 2007 at Koldam. This was 30 meter deep and 50 meter up. So now the project is commissioned and under operation. So a lot of formwork was required, and you can see the reinforcement is there, my formwork is there, and again I accept my small mistake in 2007 is I forgot to give a small holes for air vent, because the shape of the formwork is such that when you do concreting, lot of air comes out, but I had not left any hole in the formwork to allow the escape the air. So there is no escape route. So what happened? People are masala lagao baad mein. Okay. So a lot of mistakes do happen. You have to accept them and move ahead, understand how to repair them. Okay. So
The modern way for form.
that audio is not working, so you may not even enjoy now. It's 8 o'clock. So these are the various references which I have used for preparing this presentation. So I'll think we'll be taking Q&A session afterwards. So if you will be taking Q&A afterwards, so happy Raksha Bandhan from my side. Thank you.
Thank you very much, sir, for the wonderful lecture. Before we proceed with our second lecture, I would like to call upon stage Srinivasan Mudliyar to give a brief introduction of one of our esteemed guests, Engineer Mukund Limaye.
It's a great pleasure again to introduce Limaye sir. I had met him 2 years back at his residence. It was 9 a.m. in the morning, and like he called me to come and meet at 9 a.m. in the morning. And when I went there, he was all set in formals. Sir, एवढं लवकर तुम्ही कुठे चाललेत? ऑफिसला जायचं आहे मला. सर ऑफिस आता पण जाता? Oh, and how old are you now? I mean, how young are you? He said, in 15 days, I will be turning 85.
Disconnected.
And today, he's 87 and he still goes to his office every single day. He's Engineer Mukund Limaye, founder of firm Struck Art Consultants and GM Limaye and Associates, which was started in 1991. He's 1960 BE Civil graduate from Walchand College with over 65 years of unparalleled experience in structural design, proof checking, audits, and engineering consultancy. He has worked with government bodies, private industrial giants like Reliance, L&T, Godrej, overseas clients, having designed bridges, jetties, tall structures, offshore platforms, and complex foundations. He has undergone training at London for design of offshore platforms, topside, visited Nigeria in connection with site selection, also visited Thailand to monitor the vibrations developed in structure and to suggest modification to foundation and the structure. He is also a KDMC empaneled quality auditor. We are truly privileged to have him here amongst us. Limaye sir, please. Madhav sir, please welcome Limaye sir.
Our chief guest and guest of honor, if you could join Madhav sir in felicitation of Mr. Limaye sir. A huge round of applause. Sir, please a few words.
माझं नाव मुकुंद शंभूराव लिमये. मी 1960चा ग्रॅज्युएट आहे फ्रॉम वॉलचंद कॉलेज ऑफ इंजिनिअरिंग. आणि आता 60 वर्षाचा मोर दॅन 60 इयर्सचा माझा एक्सपिरियन्स आहे. मी बरोबर 25 वर्ष हम्प्रीजमध्ये
Connected.
काम केलं आणि मग 91मध्ये मी माझी स्वतःची कंपनी चालू केली. आणि माझ्याबरोबर माझेच मेवणे फडके म्हणून होते, त्यांचाही मला खूप मदत झाली. आणि त्यावेळेला मी फॉर्मवर्क वगैरे बरेच डिझाईन केलेली आहे. आणि इंडस्ट्रियल स्ट्रक्चर्समध्ये मी
Today we have with us Mr. Keshav Chikodi. Sir, if you can please come, and I request Madhav Chikodi sir to felicitate him. Chairman of IIA, Mr. Keshav Chikodi. So before we proceed with the next lecture, we would like to felicitate our first batch of supervisor training members. Basically, Madhav Chikodi sir has already briefed about this, and even our secretary Srinivasan has briefed. But apart from that, we build buildings, we build bridges. But the basic thing that we have to build first is our team. Now, within our team, to bridge the gap between the drawings or the technical drawings that we prepare in our office and on the work which is going on site. Now, many a times, as a structural engineer, I am faced with this conversation. अरे सर जरा फिटर से बात कर till date in the market of Kalyan Dombivli, it was very difficult to hire an engineer, a full-time engineer who would, or a project manager who would take care of all the drawings and communicate it properly to the site. But now, since the era is changing, we have challenging structures here. So there is a need for supervisor training or a soft training which will guide them to understand the drawings in a better stage. So as a local center, it was our responsibility which we think we have fulfilled. So I will call upon all the successful candidates one by one. If you can please come here. Mr. Shailesh Sonawane, huge round of applause for our very first batch.
I request Harshay sir and Vibhas to join.
Mr. Subhash Salve. Mr. Jogendra Jadhav. Mr. Hemant Matre. Sir, Jogendra Jadhav receiving his certificate. Hemant Matre. And our final candidate, Dilip Sutare. There was a course conducted along with examination, and these 6 candidates have successfully cleared the exam. So, Mr. Dilip Sutare. We'll also invite the faculty for their felicitation and their efforts in training all these candidates. Engineer Ajay Kulkarni and Engineer Rajiv Prabhune. Can you please come on stage? Engineer Ajay Kulkarni. इंजीनियर राजीव प्रभुणे. We now start our second lecture. I would like to call Engineer Manohar Patil to introduce our lecturer, the second lecturer for today's evening.
Good evening, all dignitaries, guests, and my fellow engineers. I am pleased to introduce you our second speaker in today's function, Mr. Parag Raut. He is a seasoned professional with over 14 years of experience in the construction and infrastructure industry. Mr. Raut holds a bachelor's degree in civil engineering from VNIT Nagpur, one of the premier engineering institutes in India. Mr. Raut currently serves as a business development manager of Western region at Tata Steel, where he leads the TMT reinforcement downstream solution portfolio. In this role, he works closely with a wide spectrum of stakeholders, including structural consultant, project management consultant, contractors, government bodies, and developers, driving innovation and value in the steel reinforcement ecosystem. Before joining Tata Steel, he was associate with Larsen & Toubro, gaining valuable insights in large-scale infrastructure projects. So please welcome Mr. Raut, sir. Thank you.
क्या करते हैं इंजीनियर्स? जुगाड़. यस, कुछ और आप बताएंगे क्या काम होता है इंजीनियर्स का? यस यस, बताइए बताइए. लाइफ इजी करना. यस, प्रॉब्लम सॉल्व करना. राइट, इंजीनियर कोई भी प्रॉब्लम होता है, इंजीनियर्स प्रॉब्लम सॉल्व करते हैं. राइट, सो मैं प्रॉब्लम्स के बारे में आज बात करूंगा कि क्या प्रॉब्लम्स है इंडस्ट्री में. सो फर्स्ट आई विल स्पीक फ्रॉम अ कंस्ट्रक्शन पर्सपेक्टिव. रीइंफोर्समेंट में क्या क्या प्रॉब्लम्स है इंडस्ट्री में. ओके, सो ये मेजर प्रॉब्लम्स मैंने जस्ट हाईलाइट करने की कोशिश की है. तो आप लोग बताएंगे इसके अलावा क्या क्या प्रॉब्लम्स है, या फिर इसमें क्या आपको नजर आ रहा है प्रॉब्लम्स. मे बी आई विल स्टैंड हियर. ऑडियंस प्लीज आप बताइए. मैं मैं इंटरेक्ट करना चाहूँगा आप लोगों से, आपसे समझना चाहूँगा, सो दैट मैं उस डायरेक्शन में बात करूँगा. बताइए आपको क्या दिख रहा है प्रॉब्लम्स यहाँ पर. वेस्टेजेस, मैनुअल लेबर पे डिपेंडेंसी है. राइट, रिइंफोर्समेंट. राइट राइट, कुछ और बैक साइड से वहाँ पर क्या लग रहा है आपको पिक्चर देख के. स्पीड चाहिए होता है. राइट, कंजेस्टेड साइट्स, ये सारे इंडस्ट्री के प्रॉब्लम्स है. राइट, सो इंजीनियर का काम, एज ए इंजीनियर मेरा आप लोगों का ये काम है कि जो चैलेंजेस हम लोग इंडस्ट्री में फेस कर रहे हैं, हम लोग उसको कैसे सॉल्व करें. राइट, सो मैं आज ऐसे सॉल्यूशन के बारे में बता चाहूँगा विच टाटा स्टील हैज़ गॉट इनटू. बट आप इसे टाटा स्टील का प्रोडक्ट है करके ऐसे मत सोचिए. लुक इट एज अ सॉल्यूशन. जो आप साइट पे जब काम करेंगे तो ये सारे प्रॉब्लम्स या इसके अलावा कुछ और प्रॉब्लम्स रहेंगे विच यू कम अक्रॉस, जिसको हम लोग सॉल्व कर पाएंगे विथ सर्टेन सॉल्यूशंस विच वी आर इनटू. राइट, सो वैसा सॉल्यूशन है विच वी हैव लॉन्च्ड अंडर द ब्रांड नेम स्मार्ट फैब. कॉमनली आप लोग इसे वेल्डेड वायर मैश, वेल्ड मैश इस नाम से जानते हैं. राइट, कन्वेंशनल जो रीइंफोर्समेंट बेसिकली फॉर स्लैब्स, फॉर वॉल्स, रोड्स, ड्रेन्स, जहाँ पर फ्लैट फॉर्म में रीइंफोर्समेंट जाता है इन द फॉर्म ऑफ अ TMT. सो इट्स अ लाइक टू लाइक रिप्लेसमेंट ऑफ दैट. ओके, सो काफ़ी जगह होता है कि आपको चैलेंजेस आते हैं विद रिस्पेक्ट टू स्पीड, कि काम फास्ट करना है, अरे लेट हो गया, मेरा प्रोजेक्ट लेट चल रहा है, हाउ डू आई इंक्रीज माई स्पीड, क्वालिटी प्रॉपर नहीं आ रहा है, स्पेसिंग बराबर नहीं है, जो लेंथ है डेवलपमेंट लेंथ ठीक नहीं है। मैं सर से बात कर रहा था बिफोर दिस इवेंट, सर बता रहे थे कि कहीं पर डेवलपमेंट लेंथ प्रॉपर नहीं आया था तो वेल्डिंग कर रहे थे ऑन द साइड। सो दैट शुडंट हैपन बिकॉज हमारा डिपेंडेंसी काफ़ी ज़्यादा है ऑन द वर्कमैनशिप। सो टू अवॉइड दैट वी कैन ट्रांसफर सर्टन जॉब इनटू द फैक्ट्री, कि वहाँ से बन के आ रहा है, और जो मिनिमल काम है जो साइट पे किया जा सकता है हम लोग साइट पे करेंगे। सो दिस इज़ वन सच सोल्यूशन विच इज़ ग्लोबली बीइंग यूज्ड अक्रॉस वर्ल्ड, द वेस्टर्न कंट्रीज इन द फॉर्म ऑफ अ मैश। ओके, सो ये 3 अलग अलग रूट्स से ये मैश बनता है बेसिकली। वन इज़ थ्रू ड्रॉन वायर रॉड रूट, कोल्ड ड्रॉन वायर रॉड रूट। बेसिकली इसमें क्या होता है कि आपका जो MS वायर रॉड, माइल्ड स्टील वायर रॉड होता है, जिसका स्ट्रेंथ अराउंड 350-380 होता है, बट दैट इज़ नॉट डिजायर्ड स्ट्रेंथ दैट यू वांट इन रीइंफोर्समेंट, राइट। सो उसको ड्रॉ किया जाता है टू अटेन अ स्ट्रेंथ बियॉन्ड 550 MPa, so that while designing you get similar properties as that of your FE 550 grade. Okay, so this is one such route, the one you see on the top. Second route है air cooled rebar. So in simple terms it's a better version of reinforcement TMT rebar which can be welded, because technically reinforcement, that is TMT rebar को weld करना is not recommended. Why? Because TMT stands for thermomechanically treated rebar. So it's a hot rolled process wherein जब hot rolling होता है you have to cool it down, right? So there's a process called quenching which is nothing but passing this hot rolled metal through a water box जिसमें water spray करते हैं। So water spray करने से क्या होगा कि कोई भी गर्म चीज़ के ऊपर अगर ठंडा पानी डालते हैं तो it will immediately get cooled down, right? So उस process में क्या होता है कि tempering होती है outside से, so which forms a strength on the outer side। जो TMT में आप लेफ्ट साइड में देखेंगे, आउटर साइड में ये रिंग फॉर्म हो रही है विच इज़ एक्चुअली टेम्पर्ड मार्टेनसाइट विच गिव्स स्ट्रेंथ टू द स्टील। जो हम लोग बात करते हैं कि 550D 500D जो भी स्ट्रेंथ आता है वो यहाँ से आता है, और जो डक्टिलिटी हम लोग लचीलापन विच इज़ परसेंटेज एलोंगेशन का हम लोग जो बात करते हैं दैट कम्स फ्रॉम द इनर लेयर विच इज़ कॉल्ड डक्टिलिटी। ओके, बट TMT में ये 2 कॉन्सेंट्रिक या 3 कॉन्सेंट्रिक रिंग्स आपको दिखेंगे विच इज़ नॉट द केस विथ एयर कोल्ड रिबार, जो कि आपको राइट साइड में दिखेगा बॉटम में, बिकॉज इट इज़ एयर ड्राइड, उसका यूनिफॉर्म होता है क्रॉस सेक्शन, सो इट कैन बी वेल्डेड एंड नॉट TMT, बिकॉज TMT में अगर वेल्डिंग करेंगे तो आउटर लेयर चिप ऑफ हो जाएगा एंड देयर इज अ पॉसिबिलिटी ऑफ कॉम्प्रोमाइज ऑन द स्ट्रेंथ। जो 550D हम लोग बात करते हैं इट माइट कम डाउन टू 450 480। सो दैट इज द रीजन वी जनरली रिकमेंड एयर कूल्ड रिबार फॉर डूइंग वेल्डिंग और mesh, and that too electric fusion welding. So what is electric fusion welding, that I'll explain. So third route भी है इसमें TMT का which we do only when the client insists, या फिर स्ट्रक्चरल कंसल्टेंट बोलते हैं कि येस आप TMT यूज़ कीजिए स्पेशली फॉर हायर डाया, बिकॉज वहाँ पर आपका जो टेम्पर्ड मार्टेनसाइट लेयर होता है वो मोटा होता है। सो दैट इज़ द रीज़न ओनली इन दैट केस वी डू mesh using TMT. So this is the process which is followed for making a mesh. So इसमें जो पहला रूट मैं बात कर रहा था कोल्ड ड्रॉन वायर रॉड रूट का, सो बेसिकली इनपुट जो मैंने बताया था कि MS वायर रॉड वी यूज, राइट। सो वी यूज लेट्स से इफ आई हैव टू मेक अ 7 mm डाया mesh, अगेन इट्स अ यूनिक डाया। TMT में आपको 8, 10, 12 these are the sizes available, right? But in this wire rod route you get mesh from 2 mm till 12 mm at 0.1 mm interval. Is it possible in TMT? No. आपको स्टैंडर्ड साइज होते हैं एंड एज ए स्ट्रक्चरल कंसल्टेंट engineers you are forced to use those standard sizes like 8, 10, 12. No matter आपका requirement कम है फिर भी आपको ज़्यादा डाया यूज़ करना पड़ता है, but here it will give you a flexibility to design as close to your AST required. So AST provided versus AST required would be very close so that your design becomes optimal. Okay, so ये पहला रूट हो गया जिसमें आपको ड्राइंग करते हैं from 8 to 7, then we do ribbing which is required for bonding with the concrete, and then third process is straightening as per desired size. आपको mesh का क्या size चाहिए depending upon panel, we do customization, and the last process is electric resistance fusion welding. How different it is from the conventional welding that is being done. MIG welding होता है आपका जिसमें additional एक element add होता है जिसमें आपका loss of strength भी possible है and वहाँ पर आपका एक additional element is being added which is actually altering its chemical and physical properties which is not recommended for a reinforcement grade bar, right? तो इसीलिए यहाँ पर जो है electric resistance fusion welding use हो रहा है. If I show a closer look of it. So basically top and bottom you see there are copper electrodes through which heavy current is being passed, because of which this becomes high resistance zone and वहाँ पर आपका temperature बहुत high हो जाता है, because of which the main bar gets fusioned into the cross bar. That is how the welding is been done. तो आपका physical and chemical properties remains intact as that of the parent material that you are using for weld mesh. So इस direction में आपका main wire होता है and इस direction में आपका cross wire. Okay. So बनता कैसा है? Just to give you just summarize what is the range that is there available through these three different routes. The first was cold drawn wire rod route. I had mentioned 2 to 12 mm at 0.1 mm interval, and the size of the mesh would be length 6 meter or 12 meter depending upon the feasibility at the site and the transportation available, and width again would be 2.4 considering the width of the trailer. Similarly, for the air cooled rebar it starts from 6 till 11 at 1 mm interval. 6, 7, 8, 9, 10. अगर आपका requirement between 8 and 10 था, so you don't have any option but to go for 10. So we have 9 also available, so which will help you come closer to your AST required. Okay. And then last is TMT, जो standard size आपके 8, 10, 12 can be used. So only when the consultant or customer insists, will give through the third route, that is TMT. So to summarize the benefit, पहले तो क्यों use करना चाहिए? To solve the problems that we saw in the beginning, right? आपका cost overrun ज़्यादा होता है. There's a lot of steel that gets wasted. 3 to 4% generally wastage is considered, pilferage is considered, which won't be the case here because the customization will be done in our case. जैसा आपका layout है, वहाँ पर जितना steel लगेगा, exactly will give you the mesh placement layout, and as per that it will get consumed. So it will help you save on the wastage. Second is design optimization. So as I was mentioning that आपका requirement अगर 10 का है, so 9 can be used. If it is 8, we can give 7, of course complying to IS code requirement, fulfilling your minimum AST required. So आपका 20 to 25% steel reduction will happen. So that is the second benefit. Third is binding wire consumption. So conventionally जब mesh बनता है, slab बनता है, तो every intersection you have binding wire to be put, right? So as a thumb rule, around 10 to 12 kg of binding wire is required per ton of TMT, right? So in this case, because a mesh of 6 by 2.4, another mesh of 6 by 2.4, you are lapping one mesh with another with binding wire. Okay, so only 1.5 to 2 kg of binding wire is required. So you are saving almost 8 to 10 kg of binding wire when you are transitioning from a conventional reinforcement to a welded wire mesh solution. Then comes the lapping. Again, as a formula for lapping 50D, depending upon again the grade of the concrete, and it will depend, right? So let's say 8 mm 200 center to center is the reinforcement given. In that case, आपका 8 into 50 400 mm lapping लगेगा, right? In this case, the code recommends through SP34 detailing that whatever is the spacing plus 50 mm for a half stress zone, you have to use this much only lapping. That is 200 plus 50 would be 250 vis-a-vis 400. So आपका lapping भी यहाँ पर कम है, because जो welding हम लोग कर रहे हैं, stiffness भी better है, and then आपका concrete के साथ anchorage भी better है. That is the reason why the development length goes down. Then comes it save space, wastage. आपको काम fast करना है, आपका labor का availability is a problem these days in cities, especially during the festive season. अभी कल रक्षाबंधन है, फिर कुछ और festival आएगा. Suddenly we see that the labor availability is a problem. आपका काम slow हो जाता है. With this kind of solution which are used globally, you can maintain the speed of the construction. Almost 60 to 70% man-hour reduction is there when a weld mesh is being used vis-a-vis your conventional reinforcement. So these are certain benefits which are there, and then we offer right from designing till after sales service, because as a consultant, if you have already done work on the designing using conventional reinforcement, बोलेगा अरे मैंने already design कर लिया, मैं क्यों बार-बार ये weld mesh से करूँ? So you will have little resistance. So for that, we have a dedicated design team who will do a working for you, taking inputs from your loading parameters and share a design with you for your validation, so that your efforts are saved and we give you support with respect to design. And again, a challenge will come with respect to execution. Contractors आप बोलोगे अरे वेलवर्स नहीं है, कैसे यूज़ करना है, उनको पता नहीं है. So we have a dedicated after sales team also which will help on-site team how to identify mesh कि कौन सा mesh कहाँ लगेगा. There will be a tagging, वहाँ पर lapping कैसे करना है, how to handle those meshes. All those apprehensions would be addressed by our dedicated after sales team जो कि site पे hand holding करेगा, support करेगा till the time the on-site team gets comfortable. So it's an entire process. We have done the streamlining so that इसका adoption easy रहे. This is how the mesh laying layout looks like. ये example है grade slab का जहाँ पर आपका अलग अलग mesh कर दिया है B1, B2 किस तरीके के layout से accordingly we have done the segmentation. And on the left is the tag. इस तरीके का tagging होता है with the mesh. I'll show you. This is the IS code. ये code में कहाँ का provision दिया हुआ है. This is how the lapping is been done. Sorry. So I was saying that one mesh has to be lapped with another mesh in a conventional way. पर यहाँ पर binding वाला आपका कम लगेगा and width also, the development length also is lesser. Of course, complying to SP34 detailing norm. So quickly I will take you through what are the different applications for this mesh can be used. So पहले हम लोगों ने देखा था कि problems क्या क्या है, कैसे solve कर सकते हैं, अभी उसको use कहाँ कहाँ कर सकते हैं. So you would be working in different types of project. कोई housing and commercials में, कोई road project में काम कर रहा है, कोई bridges में कर रहा है, कोई drains में कर रहा है. Depending upon where, which organization you are, which department you are, you will work on different applications. So quickly मैं आपको बताना चाहूँगा कि कहाँ कहाँ applications इसके हो सकते हैं and what kind of benefits that can be derived out of. So first and foremost is आपका grade slab application जो कि सबसे basic है in a warehousing industrial complexes जहाँ पर आपका 8 mm 200, 10 mm 200, 10 mm 150 standard design होता है. But considering the kind of loading it has like point load UDL ज़रूरत नहीं होता है, but you are forced to go for that. So that is where we come in and give you that bandwidth or a flexibility to design using diameters as closer to the requirement you have considering the AST. Okay. And यहाँ पर ये एक example है Central Warehousing Corporation का जहाँ पर across India we have supplied for more than 25 such shades, more than 500 tons of weld mesh. We've given initially उनका design भी again 8 at 150 and think 8 at 200 था. So we had given them 6 at 225, 7 at 165. So this level of precision you will get. ये again example है मुंबई का example मैं दूंगा. Welspun one is another client, Indo Space. Then on the left side this is being executed by NCC at Navi Mumbai International Airport जहाँ पर उनका grade slab construction करना था तो उन्होंने ये इस तरीके के mesh use किए थे. यहाँ पर almost 12 meter long mesh, 2.2 meter wide. Just imagine इतना काम करने के लिए अगर एक mesh बिछाने के लिए उनको hardly 30 seconds लगते हैं lift करके place करने के लिए. On the contrary अगर conventional reinforcement होता पहले सरिया सीधा करो, कट करो, प्लेस करो, बाइंडिंग करो. सो अगेन आफ्टर दैट ऑल्सो द स्पेसिंग दैट वाज डिजायर्ड एज ए कंसल्टेंट आपने 200 स्पेसिंग रेकमेंड किया था बट एक्चुअली इट विल बी 210, 205, 195. You won't have the consistency because of the workmanship issue at the site. So here you will get that kind of precision. You see every grid that you see is precise to an mm level. This is another example of a trapezoidal drain for Delhi International Airport. It comes in the form of a roll also. When the diameter is less, that is around up to 4 mm, it comes in a roll form which can be simply uncoiled, place it, cut it, again go forward. So this helps you fast track the work. Even during the monsoon season, the Delhi International work could be maintained at a decent speed. This is the reason why they had used weld mesh. Another example is for drains. Normally drain is non-critical structure, right? Got 10 mm, 8 mm standard it is given. Steel उसमें कम लगेगा but the amount of time it takes, man hour it takes is tremendous. काफ़ी बारी headache होता है contractor के लिए भी. Steel उतना ज़्यादा नहीं है but इसमें बहुत झिक-झिक है basically. इस तरीके का feedback आता है, right? तो यहाँ पर हम लोग क्या कर रहे हैं कि आपका जो U shape reinforcement लग रहा है it can come in two forms. One is L shape, आप side पे join कर लीजिए. On the right side you see bending करके ही आपको bundling करके we are sending it at the side, and then on the left side NHAI का एक project है जहाँ पर ये एक L और दूसरा L दोनों को side पे join करके it is made into U shape. Another case is client says नहीं मुझे joint नहीं चाहिए. So what we can do? ये ऐसा U shape है, but U shape transport करना एक ट्रक में एक mesh भेजूंगा 100 kg का, so it won't be commercially viable, right? So what we do is we send it in a flat sheet format, जैसा पहले हमने देखा था. Site पे we do the bending as per desired shapes. So we are able to fulfill the technical criteria as well as make it commercially viable. So this project we have done for Agratas, which is a battery project in Sanand, and the one on the left side is for NHA. So right from the industrial project to infrastructure project, we are able to cater to the requirement of the clients. This is another example road. India में generally PQC roads, that is pavement quality concrete roads बनाए जाते हैं. In that reinforcement का तो कहीं नामो निशान नहीं रहता. It's only dowel bar that is being used, right? But in Western countries, CRCP, continuously reinforced concrete pavement, is extensively used, right? Because it gives you better quality of ride. Generally cement road पे हम लोग जब drive करते हैं तो ये ऐसे vibrations आते हैं, comfort नहीं होता, right? But when it comes to tar road, थोड़ा एक smooth आता है. Why? Because in PQC you have smaller panels, joints आता है, because of which the ride quality is not that good, and also जो pavement का thickness भी है generally 250 mm रहेगा, 300 mm रहेगा, depending upon what kind of subgrade modulus you have. With CRCP, IRC code 101 is recommending to use reinforcement. By introduction of reinforcement, the depth of the pavement can be reduced. अगर पहले 250 था, I'm just giving an example, 250 से 200 कर सकते. We have done such successfully executed such example in Plasto factory in Nagpur. There are factories in nearby Pune also, Mumbai also we had done such work wherein we had converted PQC road into CRCP with introduction of welded wire mesh. So आपका काम फास्ट हो रहा है, पेमेंट का कंक्रीट का थिकनेस कम हो रहा है, तो आपका कॉस्ट बच रहा है, राइट? ऑफ कोर्स स्टील का कॉस्ट बढ़ रहा है वहाँ पर, बट इट इज कंपनसेटिंग द cost reduction that you are having because of the savings on the concrete. So ultimately आपका end में पैसा बचता है, because whenever a new solution is being introduced, हर कोई बोलता है अरे पैसा कितना बचेगा, right? Then comes the technical part and then comes the execution part. So here, although it is from Tata Steel, normally Tata Steel का नाम जब आता है अरे आपका product बहुत premium होता है, बहुत पैसा लगता है, that is not the case here. It will only be used only when it is creating value for the customer. आपका सेविंग्स हो रहा है 10 to 12% मिनिमम एट द एंड, तभी क्लाइंट आगे का बात करता है. सो दीज आर अनदर एग्जांपल लाइक डेस्क स्लैब्स, जहाँ पर आपका अगेन सैक्रिफिशियल फॉर्मवर्क की तरह अगर यूज़ हो रहा है. सर ने फॉर्मवर्क के बारे में बात किया, तो वहाँ मिनिमम रीइंफोर्समेंट क्राइटेरिया गवर्न होता है. फिर भी 8 mm फोर्सफुली दिया जाता है, जहाँ पर आपका 4 mm, 5 mm, 6 mm कुड बी यूज. सो यू कैन सेव स्टील हियर एज वेल. ये आपका सस्पेंडेड स्लैब के लिए, बिकॉज मोस्ट ऑफ पीपल इज इंटरेक्टिंग are into housing and commercial segment. So see कितना टाइम लग रहा है 3 लोगों को उठा के mesh रखने के लिए, इतना reinforcement करने के लिए, hardly few seconds, right? Bend करके. वही अगर conventional करना होता तो पहले cutting, placing, फिर चाय का ब्रेक, फिर बांधना, फिर आधा बांध दिया, फिर next चाय का ब्रेक, फिर दिन भर में किसी तरह वो काम हो जाएगा. फिर 2 से 2.5 दिन लगेगा for 2 to 2.5 ton of reinforcement work. With weld mesh, same work can be done in 6 hours to 8 hours, depending upon what kind of complexity it has. Right? साथ में चेयर बार्स भी इसमें दे दिया, आपका स्पेसेस दे दिए, so you get a precise reinforcement and faster work is being done. Then comes PT slab, commercial जहाँ पर आपको longer span का बनाना है, of course PT slabs are being recommended, right? So वहाँ पर भी आपका जो nominal reinforcement है bottom and top, so you can use weld mesh here. Then for raft also, wherever G plus 5, 6 smaller buildings are there, 16 mm is being used, so it can be replaced with 12 mm with, of course, complying to your AST requirement. We had used here top, we had used 11 at 100 and bottom it was 12 at 100. Precast again is picking up, it has been mandated now to go for precast in various NHI projects. Likewise in various government projects also, government of Maharashtra also is looking at this aspect of how precast can be made mandated at least to certain structures so that the speed and quality can be achieved. This for boundary wall it was used, this is for again trenches. This is we had supplied for this high speed bullet train project. It's for the noise barrier wherein 4 mesh was used. This is again for Ahmedabad Mumbai bullet train project. For the cable duct tray we had supplied this meshes in a bent form also for the cable duct trays. So here in one direction it was 6 mm, in another direction it was 10 mm, even the spacing can be customized. So you have all the flexibility in the world to design as you want in terms of diameter as well as spacing. And last is tunneling. A lot of tunneling projects are going in and around Mumbai. So for tunnel lining, we have supplied to Ritwik projects. This is for gunneting over MS pipes. This comes in roll form, lower dia. This is for hollow core slabs. This is for waterproofing, lower dia 2 mm. So again, just to tell what are the application areas where housing and commercial buildings can use. So one is suspended slab. This is a recap I'm just talking about. Walls for your reinforcement, be it structural or non-structural wall, this can be used. Then comes retaining wall, roads, I talked about drains, and then PT slab. This is how it is being transported in 3 forms, either roll forms if the dia is lesser, 6 meter by 2.4 meter, and again if you want 12 meter, that also can be said. So that's all from my side. So if you have any further query, please connect with me or my team over here. And we have a sample also for the display, just to take a look.
Thank you, Parag, for this lovely lecture. And I hope we will definitely look out, or our team of engineers who are present here today will definitely reach out to you for such kind of requirements. Now, before we conclude our program, I would like to invite Rajesh Thackeray sir to come here and give a brief introduction about our guest, chief guest, Bhushan Harshe sir. And then we would like to hear a few words from him.
Good evening, friends. Today we are privileged to have Engineer Bhushan Harshe sir as our chief guest for this wonderful program. Harshe sir is presently posted as Superintending Engineer at MMRDA Dombivli Division Office, MIDC. Under his strong leadership, his office is providing and successfully managing water supply to all MIDC areas of Thana district and Ulhasnagar, KDMC, Badlapur, NMMC, Thane, Mira Bhayandar municipal corporations, and many local bodies of villages in Thane districts. Very vast area and challenging job his team is doing. Harshe sir has been continuously working hard since joining the MIDC to improve the infrastructure facilities in the MIDC areas. He had also carried out remarkable work during COVID period on behalf of MIDC. Under his leadership, he had handed over 300-bed COVID center with oxygen facility to Sambhaji Nagar Municipal Corporation in record time period of 16 days. Because of his remarkable contribution, Harshe sir had been awarded by Lokmat Excellence International Award in 2024 at Baku, Azerbaijan. So to summarize, Harshe sir is doing wonderful work in the field of industry, industrial development, environment awareness, pollution control, water supply, drainage systems, effluent treatment plants, road networks, and so many things in MIDC areas. I welcome Harshe sir and request him to give his valuable address to us.
Namaskar. Our esteemed faculty, honored guests, there are some students and young professionals. Very good evening to all of you. I am delighted to be here on Raksha Bandhan's Eve as a chief guest for this technical lecture sessions. The lectures are very informative and innovative. As our faculty said, formwork was just like a jugaad technology in our early days. But with the passage of time and the accidents happened, it is actually very important to note the new trends to be adopted, and also the mechanized reinforced solutions that our faculty very well said here. Actually, you all know that the proper workmanship and proper implementation of technology is very much important for the safety and faster constructions. Okay. I would like to commend our organizers, Indian Society of Structural Engineers, along with Tata Steel. They have organized a very knowledgeable and very informative session here. This initiative will definitely foster the innovation and success in future. For the youngsters, the students and young professionals, I would encourage them to involve in these new trends so that their energy along with their skill and knowledge will definitely shape the construction in future. Thank you. Thank you once again for making me feel proud to be a chief guest. Thank you. Thank you.
I would like to call upon stage Ram Marathe sir to give a brief introduction about our guest of honor, Vibhas Azrekar sir, before we can hear Vibhas sir.
Good evening. I'm audible? It's do me a great pleasure to introduce a highly accomplished and dedicated civil engineer, Sri Vibhas Azrekar sir. With over 35 years of distinguished service in the BMC, he has contributed significantly to Mumbai's infrastructure, from sewerage planning and operation to stormwater drains, road construction and building development. Sir holds the diploma in civil engineering in 1987, and he is the 16th in top in Maharashtra. Then he completed AMI. He also stood first in Maharashtra. Then gradually, he completed his ME in structural engineering, one of the best college in Maharashtra is VZTI. Notably, he has worked as an official critical project like the Thakur Village and Lokhandwala sewerage layouts, Modra pumping station, and currently lead the landmark building project, including the restoration of Crawford Market, Babu Tenu Mandal, and iconic 48-story Shirodkar Market building. In his career, he has not only shown the technical brilliance, but also the administrative leadership, when serving as Assistant Commissioner, sir, during the sensitive situation lights, floods, and landslide. Presently working in building construction as a Deputy Chief Engineer. So, friend, please welcome dynamic and humble personality. So, let's welcome Sri Vibhas Achreter, sir. Round of applause.
हॅलो, आवाज येतोय माझा? धन्यवाद. शुक्रवार शनिवार रविवार सुट्टी असताना पण आपण सर्व उपस्थित राहिलात आणि मला इथे बोलवल्याबद्दल ISSE इन्स्टिट्यूशनचे पण मी आभार मानतो. माधव चिकोडी हा माझा शालेय मित्र आहे, परंतु माधव चिकोडी, श्रीनिवासन आणि या टीमने हे सर्व जे अरेंज केलेले आहे ते फार छान सुटसुटीत आणि आटोपशीर केलेलं आहे. आता होते कार्यक्रमाची सांगता आहे असं मला वाटतं आहे, त्यामुळे मी जास्त वेळ घेत नाही. हा एक उपक्रम छान केला. साईट सुपरवायझरना टेक्निकली तयार करताय तुम्ही, की जेणेकरून इंजिनियरवरचा भार कमी होईल आणि साईटवरती ज्या महत्त्वाच्या गोष्टी आहेत, जिकडे स्ट्रक्चरलची कॉम्पेन्सेशन करू शकत नाही आपण, त्या गोष्टीवर लक्ष दिलं जाईल. आणि इतर मान्यवर आणि तज्ज्ञ लोकांचे लेक्चर्स पण मी ऐकली आहे. आणि आता मी रिटायरमेंटच्या एजला आलेलो आहे, तर आता मी हे असे कार्यक्रम उपस्थित राहीन. सन्माननीय पाहुणे नसेल तरी एक उपस्थित म्हणून तरी मी येत जाईन आणि मला बोलवावं अशी मी विनंती करतो आणि म्हणजे 2 शब्द संपवतो. धन्यवाद.
Now we will conclude the program with a vote of thanks from Amod Lumand sir.
हॅलो अँड गुड इव्हनिंग. एक छानसा कार्यक्रम पूर्ण पडला की एक सोहळा असतो की आभार प्रदर्शनाचा. ती जबाबदारी माझ्यावरती टाकलेली आहे. एका कार्यक्रमाकरता कित्येक लोकांची इमॅजिनेशन, कित्येक लोकांचं हार्डवर्क, कित्येक लोकांचं प्लॅनिंग हे सर्व आवश्यक असतं. आणि मग तो प्रोग्राम पार पडला की ह्या सगळ्याचा उल्लेख होणं फारच आवश्यक असतं. मी सुरुवात करीन भूषण सरांपासून. दरवेळी म्हणजे असा आमचा एक्सपिरियन्स असतो की चीफ गेस्ट यांना यायला उशीर होतो आणि त्याच्यामुळे प्रोग्राम उशिरा चालू होतो. तर सर तर टाईमच्या आधी झाले होते. व्हेरी सॉरी, तुम्हाला थोडा वेळ थांबायला लागलं. ओके, पण तुमची उपस्थिती अत्यंत भूषणाव होती आणि तुमच्या उपस्थितीमुळे आम्हाला सर्वांना अत्यंत हर्ष झाला. आचरेकर सर, येस, तुम्ही पण वेळात वेळ काढून आलात. तुम्ही म्हणालात तसं की फ्रायडे सॅटर्डे शुक्रवारची संध्याकाळ असते, प्रत्येकाचे विकेंडचे प्रोग्राम ठरलेले असतात, तसे तुमचेही काही ठरलेले असतील. त्याच्यातल्या त्यात तुम्ही वेळ काढून आलात, 2 शब्द सांगितलेत आणि परत आता तुमची अवेलेबिलिटी सांगितलीत. तर आम्ही तुमच्या एक्सपिरियन्सचा आणि तुमच्या अवेलेबिलिटीचा नक्कीच उपयोग करून घेऊ. त्याच्यानंतर जी आपली 2 टेक्निकल लेक्चर्स झाली त्याच्याबद्दल, स्ट्रक्चरल इंजिनिअरिंग, आपण मोस्टली इकडे स्ट्रक्चरल इंजिनिअरिंग प्रॅक्टिस करणारे लोक आहोत. स्ट्रक्चरल इंजिनियर्स आणि त्यांचा काउंटरपार्ट आर्किटेक्ट यांना फॉर्म हा शब्द फार महत्त्वाचा असतो. आणि फॉर्म मिळवण्याकरता जी गोष्ट होते, तर तसं मला फॉर्मवरती फार काय माहीत नव्हतं, अजूनही काय माहिती अशातला भाग नाही. इंजिनिअरिंगमध्ये कॉलेजमध्ये शिकताना फक्त एक प्रत्येक एक्झामच्या आधी एक फॉर्म भरायला लागतो, तो फॉर्म तेवढा माहिती होता. ओके, किंवा रुईयामध्ये काही फॉर्म दिसायचे, ती गोष्ट वेगळी. तर एकंदर फॉर्मवर्कवरचं लेक्चर फारच छान झालं. ही लेक्चर्स अशी असतात की आता एकंदर ओव्हरऑल आपलं लाईफ बघितलं तर 3 पार्टमध्ये डिवाईड करू आपण. आय नो अशा काही गोष्टी असतात, आय नो आय डोंट नो अशा काही गोष्टी असतात आणि आय डोंट नो अशा काही गोष्टी असतात. पण ह्या अशा लेक्चर्समुळे, फॉर्मवर्कवरच्या लेक्चर्समुळे, तसंच वायरमेश टाईप ऑफ एन्फोर्समेंटच्या लेक्चरमुळे कित्येक गोष्टी अशा असतात ज्या आय डोंट नोच्या कॅटेगरीमधनं आय नोमध्ये येतात. त्याच्यामुळे ही लेक्चर्स खूपच उपयोगी होती. राऊत सर आणि अभ्यंकर सर, धन्यवाद. तुम्ही खूपच इन्फॉर्मेटिव्ह लेक्चर दिलीत. त्याच्यानंतर ह्या एकंदर ग्लोब स्क्वेअरचं मॅनेजमेंट यांचे मी आभार मानीन. त्यांनी हा हॉल अवेलेबल करून दिला त्याच्याबद्दल. फोटोग्राफर्स यांनी प्रोॲक्टिव्हली त्यांचा रोल हे केला. कुठल्याही प्रकारचे काही गायडन्स नाही, ते स्वतः पुढे येऊन इनिशिएटिव्ह घेऊन फोटोग्राफ्स देत राहिले आणि याच्यामुळे आमच्या बऱ्याचशा चांगल्या मेमरीज तयार होतील. थँक्यू. महत्त्वाचं त्याच्यानंतर लिमये सर, म्हणजे श्रीनिवास म्हणाला, श्रीनिवास आय थिंक माझ्या 15 वर्ष मागे आहे. मी 15 वर्ष आधी त्याच्या PE झालो, पण श्रीनिवासला ते गाईड म्हणून अवेलेबल होते. तर तसेच सेम केस माझ्याबरोबर होती. कित्येक वेळा प्रॅक्टिकल लाईफमध्ये गोष्टी अशा असतात की ज्या IS कोड किंवा पुस्तकं ह्याच्या पलीकडे असतात आणि साईटवरती किंवा डिझाईनमध्ये काही प्रॉब्लेम आले की वी एंड अप हॅव्हिंग स्लीपलेस नाईट्स. अशा वेळेला सरांसारखे गुरुतुल्य माणसं जी आहेत त्यांचे जस्ट एक 5 मिनिटाची जरी आपण इंटरॅक्शन केली तरी आपलं लाईफ खूप सिम्पल होऊन जातं. सो थँक्स अ लॉट सर, आणि यू विल ऑलवेज बी अ इन्स्पिरेशन फॉर जनरेशन्स टू कम. त्याच्यानंतर फॅकल्टीज ऑफ सुपरवायझर कोर्स. माधव चिकोडी सरांचं एक स्वप्न होतं की आपण एक सुपरवायझर कोर्स घेऊ आणि त्याप्रमाणे तो कोर्स सुरू झाला. आणि आमच्या टीममधल्या लोकांनी, काही लोकांनी उत्स्फूर्तपणे त्याला फॅकल्टी हा रोल करून फार सुंदर प्रकारे तो कोर्स कंप्लीट केला. नुसतं कोर्स लेक्चर देणं सोपं आहे, पण त्याच्या पलीकडे एक लेक्चर घेऊन खरोखरच ही आपण घेतलेली मेहनत कामाला आली आहे की नाही, त्यांना किती कळलं आहे ह्याची पण खातरजमा केली गेली. आणि आज यशस्वी कॅन्डिडेट इथे उपस्थित होते, त्यांची सर्टिफिकेट रिसीव्ह करण्याकरता थँक्स अ लॉट. आम्ही तुमच्या डोक्यात भरपूर आयडिया टाकलेले आहेत आमच्या फॅकल्टीनी किंवा टीमनी, आणि ते प्रोटेक्ट करायला तुम्हाला हेल्मेटही दिलेलं आहे, त्याच्यामुळे काळजी घ्या. येस. त्याच्यानंतर त्याचबरोबर IIA कल्याण डोंबिवली चॅप्टर्समधनं आर्किटेक्ट सातवळेकर सर आणि केशव चिकोडे सर उपस्थित होते. थँक्स अ लॉट. बऱ्याच जणांचा मी उल्लेख केला, कदाचित अनावधानाने कोणाचा उल्लेख राहिला असेल तर मी त्या सर्वांचे आभार मानतो आणि हा कार्यक्रम संपला असं डिक्लेअर करतो. थँक्स अ लॉट.